All right, a very quick reminder. For tomorrow, as we mentioned before, we have our makeup lecture, okay? 1:30, and then CLHJ. It will be the same time and same place next Friday as well, but for this Friday, tomorrow, okay? If you can count, that'd be great. If you cannot, I'll try my best to record as usual, okay? Just try your best to count. You can also ask questions. All right, so today the topic will be a little bit logical, okay? A little bit logic we got to do, but we'll still draw a connection to the code that you have been doing, okay? It's called subcontracting. Basically, the issue is pretty, not many slides to go over, but I think I do want to go over some rationale of why we're doing this lecture with you. That's quite important. You can definitely feel free to apply that to your projects or other labs, okay? Subcontracting is really about what happened to design by contract when you have inheritance. If you have a precondition in your parent class, how does that precondition inherit to the subclass? How exactly? If you just inherit verbatim, then did you break the door? Wow. All right. Anyway, so if you got contracts in your ancestor class, how are they going to be inherited to the descendant classes? Okay, that's kind of the issue. All right. All right, we talk about inheritance, before the reading week, code reuse, and substitutability. Okay, we wouldn't review this part, but just to bring you to the context. Polymorphism, dynamic binding, we have been reinforced in so many patterns. Okay, and now subcontracting is what we're going to talk about today. Okay, runtime behavior check. Basically, for subcontracting, we're going to talk about two stages. Stage number one, when you are designing your contracts, how can you judge whether the precondition you introduce in the ancestor class is still going to work for the descendant classes, right? You want to see that kind of issue. So be two issues for subcontracting. Number one, whether your design for the contracts is suitable or not, number one. In that case, you have to do a little bit analysis, like what you did back in 1019. Very, very light. It's not heavy. Number two, given that your contracts are properly specified in precondition, postcondition, also you got inheritance, how are they going to be checked at the runtime? Okay, that's another issue. So two issues over here. One is about judging your design, whether that's appropriate or not. And number two, what's going to happen at the runtime? Okay, we're going to talk about these two issues. Okay, before that, let's get yourself comfortable about the logic. Okay? Very light, not very heavy. Let's say we got two predicates, well, two Boolean conditions, P1 and P2. Let's say we are using P1 and P2 as preconditions, right, in different places. And now let's have the following definition. Okay, we say that precondition P2 requires less than P1 if P2 is less strict, and also if P2 is less strict, that means it allows more input value to go through, right? It's less strict, so that requires less than P1 does. Okay, can any one of you tell me, if I tell you this kind of informally, what would be the formulation of this relationship between P1 and P2? If I say P2 is somehow less strict than P1. Uma first, yes. Actually, nothing about, well, you got to do something about it, right? Yeah. I'm teasing you, that's fine. That's fine, you're fine. Okay, yes, please. You have about ancestor and descendants. But here, we actually, you know what, you can see here, there's no inheritance here. We just talk about predicates. Just about Boolean conditions. If I somehow tell you, if I use, I'll give you one example. Okay, I'm going to use that example as well later. Let's say this guy here, okay? Let's say I have two possible things, right? If I got x larger than 0 versus x larger than or equal to 0, right? So these are two different Boolean conditions, right? Somehow we want to know which one being used as a precondition, which one require less, and which one require more. Can you see which one require less? Greater than 0 require less? Are you sure? Be careful. Okay, now the question is, let's just call this 1 and call this 2, okay? Does 1 require more or less than 2? That's the question. Oh, no, no. Actually, does 1 require more or less than 2? So your answer should be either more or less. I heard more? OK. Why is that?
Because it's got one fewer value that it'll accept, and you can't have exactly 0, so it's more strict.
So it sounds like if you say some precondition requires more, that means there will be at least some values that wouldn't be allowed by that particular strict precondition. For example, in this case, you can see, OK, the answer should be it requires more. OK? For example, x is not allowed by 1, but, oh, sorry, x equals 0. OK? It's not allowed, but is allowed by 2. OK, make sure you're comfortable with this. I'm still talking a little bit informally here before we get to predicates, more formal. So either you can say 1 requires more than 2, because 1 would not be accepted. Or you can say symmetrically, 2 requires less than 1, right? More or less, they're kind of symmetric. OK? OK, let me just write it down. 1 requires more than 2, whereas 2 requires less than 1. You can say either way. OK? Now, let's go back to your 1090. How can we formulate this particular relationship? When I want to check to see whether one precondition, P1, require more than P2. Cardinality, but they are simply Boolean value, true or false. Where do you have cardinality? OK, I can kind of see, I'll try to build out on what you're saying. So you're basically saying we have a set to say all the x such that x is larger than 0. Right? It's a set, right? And then versus there's another set, and then x larger than or equal to 0. Right? Apparently for this set, oh, by the way, it's a set comprehension notation, right? If you're not comfortable, let me know. OK, I assume you know that. So now starting value will be 1, and then 2, and then 3, all the way to, of course, the largest integer value, or infinity, conceptually. And this guy over here will be 0, 1, 2, all the way to here, right? So now that means this guy here is somehow allowed in one, but not the other. Okay? Basically, you have this subset relationship. However, thinking about this way is good intuitively, but you don't necessarily want to convert your Boolean condition to the set of satisfying values always. There's something equivalent to it. Back in 1090, if you say a predicate, the set of satisfying value of a predicate is a subset of the other one, what does that really mean? Huh? Yes? Say it again, sorry. Yeah, exactly. So what you want to say is, so this is equivalent to x larger than 0 implies x larger than or equal to 0. So this is the eventual thing we want to get, right? Once you get more mechanical. OK, let me summarize quickly. You were given two arbitrary Boolean conditions, P1 and P2, right? And somehow you want to know which one, when used as a precondition, will require less or more. Okay? So now here's a rule. Okay? Let me summarize again. Okay? So now if you somehow have P1 implies P2, and both of them are used as precondition, and this is just another precondition. If you can somehow prove this, of course, you can either prove by supplying some complex example or just by just some reasoning. Anyway, I'll get to that when we talk about examples. If we have this particular relationship, that simply means P2 requires less than P1 because P2 allows more input values. Without a precondition violation. Okay? Of course, Whether to use x larger than 0 or x larger than equal to 0 as precondition is completely up to you. You got to judge. Okay, first of all, let's get that straight. All right, just make sure you're comfortable with this. It's only a background check. All right? And now, okay, that's the set comprehension we just talked about. Okay, and that's the implication. And that's kind of the example I just talked about. Okay, a very small test for you. Having this, what would be the least? What would be the precondition that requires the least? No, just in general. Let me say it again. What would be the precondition, being a Boolean condition, that requires the least? True. Yes, that's true. And I'm pretty sure you can tell me what would be the precondition that requires the most. False, right? So I would say typically, unless you really know what you're doing, you wouldn't really have a precondition being true or false, especially false. If you have a precondition being false, that's pretty useless. Okay, pretty much. Okay, very good. Oh, why would the precondition being false so useless? Why is that? Yeah, because the client calling that will always get a precondition violation. Doesn't matter what input value they give, right? Intuitively. Okay. All right, guys, it's very similar. Okay, for the second one, I wouldn't bother you too much. Let's double check. So now, previously we talked about two predicates, just P and Q. Just P. And now let's talk about another two Boolean conditions. And we talk about postcondition invariance together because you can think of invariance is pretty much like the postcondition for every feature, right? As we said before. Okay. Now, we have another definition over here. Given two Boolean conditions, we say that a precondition Q2 ensures more, which means it guarantees more to the clients once they call the feature. Q2 ensures more than Q1 if somehow Q2 is stricter, which means it's like a stronger postcondition. So that means it would be harder to actually satisfy this particular stronger postcondition. And that means fewer values can satisfy that. Okay? For example, let's say you have something like this. Okay, so now let's say you have a sort method, okay? Where you simply got, let's say, input over here, array of integer. Okay, and then you can say ensure over here. Okay, so now let's see what we can do. One postcondition can be, I'll just give you options, okay? Let's say number one, we simply say for every I such that, let's assume that, okay, lower starts from 1. 1 less than or equal to I less than or equal to input dot count. It is the case, okay? And then you'll simply say input at position, oh, you know what? Let me say -1 just to be safe. I less than or equal to input I plus 1. Okay? You can see what this is doing, right? Just make sure the array is sorted in some non-descending order, right? It could be equal, right? Let's talk about number 2, which is going to be very similar, very, very similar. So what I would do is for number 2, let me copy this guy here. I'm just going to change its sign. Oh, before I do that, I may want to change to make sure it's really obvious to you what's going on. Color blue, okay, like that. And then 2 over here. So now I'm going to change this guy over here into strictly less than. So now, which postcondition ensures a little bit more? Which one is actually harder to actually satisfy conceptually? The number 2, right? You can think about, okay, First of all, you can see that this guy here is actually stronger. It requires that it must be strictly less than. On the other hand, this one is actually a little bit weaker. Okay, so that means this one, less output value is going to satisfy. Will be able to satisfy. Okay, because it got to be strictly ascending order. Okay, yes.
Kind of a little bit off topic, but like if we have this as a postcondition,
yeah.
we have to ensure that one of the preconditions would be that there are no duplicates in the.
Yes, exactly. Yeah. So yeah, you're exactly right. So for this particular postcondition, I just want to contrast the two versions. So when you write them, you should know which one means what. But of course, if you choose number 2, that means you want to make sure you got unique numbers in the precondition. Yes, absolutely. You can omit that. All right, guys, we'll see more examples. I want to give you an idea. That's that kind of thing you want to judge. Okay, so now number 2 over here. Okay, would you agree number 2 is going implies number 1? Right? Okay, because that's stronger. So that means number 2 ensures more than number 1. Okay? Yes?
So if 2 is stronger, does that mean it requires more?
No. When we say require, we only talk about input values. When we talk about input value, it's before you try to execute the implementation. When we talk about ensure, it's already after the implementation has been executed. Right? So we talk about pre and post conditions separately. Yeah. So here you're basically saying any client calling the sort method over here or sort command, what they're gonna get, if they get 1, they only guarantee the array is going to be sorted in non-descending order. In that case, it can be the element might still be the same, right, between any adjacent pairs. But for number 2, it's actually stronger. It can guarantee a little bit more on that, right? Yeah. Good. Okay, that's good. Okay, let's go back here. Okay, similar exercise for you. Okay, that's just another example. You can look. What would be the post condition that ensures the most? Because there will be no output value that can ever make this particular post condition false. True, right? Because, okay, first of all, it is false conceptually. If a post condition is false, so that means somehow the supplier is so strict on themselves, they will never be able to achieve the goal. But is that useful? Not very useful. That means it doesn't matter how well they're doing. Even though they got a very a linear sorting algorithm, it will still actually fail the sort. Doesn't matter, right? Okay, and what about the post condition that ensures the least? That's also not very useful. Why? If I simply got a post condition that's true, anything can happen, right? Exactly. So again, the lesson is when you decide contract, you don't want to go extremes, right? You don't want to go either true or false, but you should understand if you don't go for the extremes, what's happening there, right? All right, and then let's go a little bit. Okay, that's the background I want to go over, and then we'll see more concrete examples. Okay, inheritance and contracts. Okay. Okay, let's review just a little bit about the smartphone example. Okay, remember we got smartphone, and then we got basically different descendant classes, iPhone 6s Plus, etc. Right? Okay, things like that. The only thing I want to review was like this, right? It's a very quick reminder. I wouldn't spend too much time. Basically, we talk about substitution. Whenever you are given certain inheritance hierarchy, right? You got some class over here, you got some descendant classes, the hierarchy can be as complicated as it might be needed. For example, your project, right? Your inheritance hierarchy for the language structure might be quite sophisticated. That could be one example. Let's say you're given an inheritance hierarchy over here. Under this context, if I try to do V1 is assigned to V2, and let's say the static type for V1 and V2 come from any of the 2 classes in the hierarchy, right? What would be the substitution rule that we talk about, right? We say over here, somehow conceptually, static type of V2 can fulfill all expectations on the static type of V1. One example would be, let's say the static type for V2 is, let's say, C over here. Okay, that's a C over here. And then let's say the static type for V1 is A. In that case, that'll be okay because C is guaranteed to have all the code that's inherited from A, or even more. So whatever you expect on A can be fulfilled by C. Okay, that's basically what we said before about inheritance. Okay, but now we're going to go a little bit further to say, when you say V2 can really fulfill all the expectation of V1, not only that, you want to make sure there'll be no surprise when you try to substitute V2 for V1. Okay, so we're going to talk about that kind of substitution again, from a different perspective. Okay, that's basically what's going to happen. Okay. Okay, so now what we're going to make sure is whenever you try to do substitution, you want to make sure the descendants is not going to require more on the input values. And also, they are not going to ensure less than what their parents promised, okay, intuitively. For example, let's say if I declare my phone as smartphone, can I substitute it by a iPhone 6s Plus, for example? It depends on whether the iPhone I'm substituting, as long as it does not require more on the input, for example, battery level. And also, it does not ensure less, let's say, sending me the daily reminder. As long as it satisfies these two criteria, it's a good design. Okay? But we're going to see example. Okay. Let's see some architecture over here before we go for concrete example, and then we can have some discussion there. Okay, okay, that's kind of the architecture I want to go over first. Okay, let's see this. Okay, again, you have the client, which is the user of the phone. Okay, they simply say my phone. Of course, to be more precise, you're going to say plus over here, right? And then my phone is typed statically. So this is static type, my phone. And you can see this architecture tells you this is basically what the phone user is expecting. All they're expecting will be just a smartphone. Doesn't matter what smartphone you're giving to me. It can be any of the descendant classes. Okay? And in this particular case, actually, I meant to put 11 Pro, but it doesn't matter. Just some subclasses over here, right? And then let's talk about, for example, if there is a particular query over there to say get reminders. I want to know what am I supposed to do for today, right? So they will simply return a list of events or an iterable of events, right? Doesn't matter. Okay. And then we talk about the same query as well. So we talk about inheritance. Okay. And now what we're going to discuss will be as follows. Let's say you declare the precondition at this level something, and also you say require else simply means you're going to declare another precondition. I'll talk about the else part a little bit later. Okay, for now, just take it for granted. Okay. If I got something here, if I got something over here, how can I judge whether 1 and 2 work together consistently? Meaning that number 2 shouldn't create any surprise to the smartphone user. Okay, we'll get there. And similarly, I also got some postcondition over here in the parent class. I also got some postcondition over here in the child class, right? And in that case, if I compare this postcondition, let's say 3 here, and also this postcondition, which is 4, how should 3 and 4 work together consistently without the case where number 4 is going to ensure less than what 3 promises, right? Basically, that's the context we're talking about. Guys, any questions so far? Any clarification you need before we see some example? Okay? Yes?
So what I'm understanding is that
Yeah.
for iPhone 11 Pro, the postcondition and the precondition should build on top of the postcondition.
When you say build on top, you don't necessarily have to repeat the pre and post condition in the smartphone in the context of iPhone 11 Pro. You can add something addition to it, or you can redefine it. I'll just put it that way informally. However, I would say we're going to talk about 2 issues over here. Number 1 is about whatever you put over there for require and ensure in the iPhone 11 Pro, would they be appropriate, number 1. Number 2, how are they exactly checked at the runtime? Are we going to check both? Or are we're only going to check one but not the other? So that's 2 issues here we're going to talk about.
So a subclass can redefine the postcondition or precondition of the superclass, but when it says redefine, does that mean it can necessarily, for the postcondition or precondition, make it stronger or weaker?
Yeah, so when I say, you know what, maybe we shouldn't use the word redefine. when we talk about redefine, it's like redefining a feature, like a query or command. You're just redefining the code. But in here, just think about you somehow adding something on top of what you have in the parent class. But whether it's strong or weaker, we'll talk about. Okay. Okay, so think about the require else and ensure more in the children's class over here. So this part over here, we're just adding something on top. But what does it really mean to add something on top? That's something we're going to talk about. Okay. Okay, let's talk about examples. Okay, more concrete, so we have some discussion here. I have one design proposed to you, design number 1. Okay. In this particular design, let's focus on precondition. Let's not worry about the postcondition. Okay. So you can see in the top, at the top, I have this particular class, smartphone, and then I talk about this particular get reminders feature. Okay, we talk about the same features. Okay, and I say redefine simply because the implementation part might be redefined. Okay, and then it's going to return the list of events, and then the require part, and require else. Just say we talk about two preconditions. Let's say this. At the parent level, we say that when you want to use the get reminders, the battery level should be larger than or equal to 10%. Otherwise, you cannot support it, let's say. And then in the subclass over here, which is a little bit more specialized, we're saying that you can only use the get reminders if somehow the battery level is at least 15%. And before I ask you the question, remind yourself, this is the overall architecture we have. For any phone user, let's say my phone, statically, they were declared a smartphone, which means all the client's expectation is according to smartphone. However, dynamically, we're actually using iPhone 11 Pro. Okay, that's kind of the setup. So now, is there any issue for this particular design? I heard yes. Okay. Jordan, go ahead.
Yes, so if you're dynamically looking at the iPhone 11 Pro,
Mm-hmm.
you have a battery level that's not suitable for it, such as 13%, then that's not going to work. It's not going to meet the precondition.
Yes. Okay. 13% is good. Okay. Let me put 13 down. Okay. That's the example we can use. Okay. Can anybody try this? Try again. Maybe I'll just. That's correct, actually. If anybody wants to speak up again. Yes. First of all, 0.1, okay. So let's talk about just about the predicates over here, right? Let's first agree, okay? Let's call this alpha, right? This is called alpha. And this is called gamma, okay? Which one is requiring less? Alpha? Okay. How do we prove it? Well, okay, first of all, you claim that alpha is, okay, you're claiming the following. Alpha requires less than gamma. That's what you're claiming for, right? Okay. So formally, how do you prove it, right? Because during the exam, I might just want to ask you, okay, first of all, tell me which one require less or require more. Okay, you tell me which one first, and then you prove it to me, right? So now this is what I expect to see. If you claim alpha requires less than gamma, what kind of a formula do you have to prove? I gotta say, somehow you want to prove that gamma, should I prove alpha implies gamma? Or should I prove gamma implies alpha? The second one, right? Okay, very good. Okay, very good. That's kind of the small step you want to pay attention to, okay? So now, I'll get rid of this just for now, okay? So what we want to prove is gamma implies alpha. Or thinking intuitively, every value that is going to satisfy gamma is also going to satisfy alpha. Is that true? That's true, right? Okay, good. Yeah, I just want to double check, right? Okay, first of all, this is exactly true. However, when you say alpha actually requires less than gamma, is that appropriate? Let me put it another way. I'll put it another way. What we said so far is exactly correct. Okay, nothing wrong. Okay, because always when you try to talk about implication, you can talk about both ways. Let me put it slightly different way. Okay? When you say alpha requires less than gamma, okay? What about this? Gamma over here requires more than alpha. This might be a little bit easier for you to see what the problem is. Ah, Eddie.
Wouldn't the top one require more actually? Because like let's say you have an array from 0 to 100.
Oh, no. Actually, when you talk about array, you can see in the require over there, we didn't talk about anything about array, right?
I know, I'm just doing an example where like you would only like there would be less things that would fit. It would fit less things at the first one than the last one. So like the second one.
Oh, not really? Are you sure? You're claiming that somehow, okay, what you're claiming is, okay, let's put the predicate down, okay? Guys, we're getting there. Okay, let's talk about this. Alpha over here is the battery level, let me say level. The level is basically larger than or equal to 10%, okay? And the gamma that we talk about over here is battery level larger than or equal to 15%, right? Okay, so far so good? Okay? You were claiming that somehow alpha actually allows more value or less value? It's more strict. That means allows less value. Is that true?
Yeah. The first one allows less.
You're claiming the first one allows less.
Yeah.
Well, just follow your thought. I just want to try to lead you to somewhere, right? You're claiming that this allows less values. Let me put a question mark. How about that? Let me help you demystify that. What will be the set of values of x such that alpha of x is going to be true? What will be the first value? 10%? 11%? All the way, right? What about gamma? Y such that gamma y. What will be the first satisfying value? 15. Would it include 10? So that means alpha is more accommodating. It requires less, not require more. Okay, this makes sense? Okay? Okay, how about this? Let me make it even more obvious to you. I know it's kind of tricky, right? But that's something we really want. 11, 12, 12, 13, 14, and all the way here. Can 10 satisfy gamma, first of all? 10? Can it satisfy gamma? No, it cannot. You can see already it's not there, right? Okay. Can 11 satisfy gamma? No. And 12 cannot, 13 cannot, 14 cannot. So the very first one that will satisfy gamma will be 15. No. The first one allows more value, so that's less strict. When we say strict, what do we mean? When it is strict, that's really disallows certain values from the precondition. Maybe you just have some problem about strict, right? Well, what does it really mean to be strict? Being strict, that means harder to satisfy, right? Okay, good. Okay, guys, that's okay. Just in case you also got confusion, that's how you justify it informally, okay? So now let's go back to here. We pretty much justify already that gamma over here requires more than alpha. Okay? Basically, every time you want to see if your precondition design is appropriate, what you're going to make sure is your gamma over here should require no more than alpha. That's basically what you want to see. Okay? So now, if it requires no more, in that case, you can state the implication over here. That's one way to do. Or you can simply give a counterexample, like what Jordan said very initially. Okay? So let me just write it down. So gamma requires more than alpha. Okay? So I would say, for example, where the battery level is 13%. Okay? That's one of the examples that was not allowed, right? Okay, 13%. This will satisfy, first of all, satisfy alpha, but it will fail gamma. Okay? When we talk about 13 over here, okay, 13 basically is 0.13 and also 0.13, right? You can see this will evaluate to true, but this will evaluate to false. All right, so what's the problem with that? Think about it. Let's think about the big picture. So the problem with this particular precondition is as follows. When the phone user over here, because statically they declare my phone to be of type smartphone, all the expectation is according to a smartphone, meaning that I should be able to use get reminders when the battery level is larger than or equal to 10%. However, dynamically, it's actually iPhone 11 Pro, in which case they have a more, like a stricter precondition. In that case, if I got 13%, which should really make a smartphone in general happy, but would it make an iPhone 11 Pro happy? Not really. So, not appropriate. It compiles, but it's not appropriate. Not appropriate. Okay, let me just go over one more point and I'll take a question. Just bear with me. Just I wanted to go over one or two more points. So when you actually look at that, okay, that's the first example we went through. We talk about precondition. We say that it's not appropriate because this guy over here, okay, that's something I didn't really say. When you try to do over here, you say battery level, that's kind of implication with state, okay? And then you just want to say, oh, I just give 12% as an example as opposed to 13, right? And then you want to somehow explain that for this particular number over here, either 11, 12, 13, or 14, those numbers are going to make the precondition of the parent class true, but it's going to make the precondition in the subclass false. Okay, that's kind of the surprise you will get. Chelsea, question.
So we have this situation where we have an iPhone 6 or the other smartphones, preconditions can't be stricter.
Cannot be stricter. Yes, correct. Intuitively, why can a precondition in the subclass not be stricter? Because if it was stricter, it's going to create some surprise to the user. If the user simply declared the ancestor class as a static type, every expectation is according to the ancestor class. But now if dynamically you got something that has stricter precondition, when the user expects something not to fail, it will actually fail. That's basically what's happening here. Question?
Yes. If you change the battery level from 15 to 5.
Okay, sure. We can do. Oh, you're basically talking about fix, right? We'll get to the fix. Don't worry.
Sorry, not the fix. I'm just saying like.
Why did you do that?
Yeah. Is it redundant, right?
You're saying, okay, let me just go back here. Let's try that. Okay, I'm just going to copy and paste the same example here, so it's clean. Okay, tell me what you want to change.
From 15 to 5.
You mean over here to 5. Okay, so what if we do that particular change? Do you think now it is okay? Yes? No?
Yes.
Okay, so now anybody want to explain? It's less strict. How do we know it's less strict? Okay, yeah, so let me just write it down, okay? So now basically all you got to show is gamma actually, okay, let me say this. Alpha over here, which is the precondition in the parent class. So now it implies the gamma. As long as this can be proved, that's okay. Which means the precondition in the child class is less strict, right? That's what we said before. So now, if we got level over here, larger than or equal to 10% implies level larger than or equal to 5%. Is that true? Yeah, of course. For example, think again, just you're allowed to sketch. So that'll be 10, 11, 12, etc. And how about this guy here? 5, 6, 7, right? Isn't that a subset? Right? Well, the right-hand side, 5, 6, 7, all the way to 9, and then 10, 11, 12, right? So it's a subset. All right. Yeah, take some time to think about it, but I just want to explain to you intuitively. Your question? Yeah. Oh, and they'll get to you. Yeah.
So you're saying like it is like the child class have weaker precondition is like acceptable, but like the stronger precondition than the parent class is not acceptable, basically?
No, basically we talk about the design of the contract, let's say precondition, in both contexts. So we're going to talk about these two contexts together. So what I'm focusing on is if we consider the fact that, for example, in this case, we had this particular precondition here, and we got this particular one over here. Is that appropriate collectively? The answer is yes. On the other hand, we'll talk about the previous example, where we got this one and also this one over here. Collectively, are they appropriate? No, right? As we explained before, because you're going to see some surprise at the runtime. Question?
Trying to answer this on an exam, what would be the crucial parts for the answer?
Oh, how do you say that in the exam? Okay, very good. So now in the exam, let me tell you exactly what you should write. Well, the pattern, of course. In the exam, let's say we have a class called A over here, and we have a subclass over here called B. Okay, and then let's say we have, let's say just some command. Okay, just for example, command. Let me only talk about precondition. Okay. Require, and then again, let me say P1. Okay. And then over here, we got another command over here, which is the same feature, basically. And then over here, we say require P2. Okay? Just set the context well. P1 here and P2 here. The question would be, are the preconditions P1 and P2 designed appropriately? Okay, that's the question. Of course, alpha and beta can be any, P1 and P2 can be any arbitrary formulas, right? That's the question, okay? What I expect to see from you is, number one, you would say, to be appropriate, P1 must imply P2, meaning that P2 is less strict. That's what you want to prove. So you may want to state the implication you want to prove, first of all. Okay? Number two, if you can prove it, just justify how you can prove it, right? If it's quite obvious, you just say according to integer arithmetic, right? Number two, prove it. And for example, if necessary, by counterexample. If necessary. For example, you can see in the very first case, we talk about using 13 as a counterexample, right? So 13 is the one that can make the precondition in the parent class correct, like a true, but it's going to evaluate to false when you talk about the child class. Okay, that's exactly one way. That's exactly one question I can ask you, but that's expected to be answered. Okay. Yes.
You know how you go back to
Yes.
So right here, because we weaken the postcondition, or sorry, the precondition.
Yeah.
So like, let's say for example now it accepts, if it's an iPhone 11 Pro, it accepts something that's battery level 7. It's like at compile time, would we have an error because like the parent is still looking for something above 10, even though runtime it would still work?
Oh, no. Actually, you know what? Whatever number, okay, you talk about compilation versus runtime, right? We are basically talking about, okay, thinking this way. In both cases, you can see in case number 1, we actually got 0.1, 0.15. In case number 2, we got 0.1 and 0.05, right? Both cases, it compiles, the code compiles, simply because all you are expecting will be a real number. Okay, that's what compilation is, right? That's basically type correct. Okay, so now, okay, when you talk about runtime, I would say now we are not talking about runtime. We don't talk about design time. we talk about how you can judge whether, before you even put down the precondition for your code, you want to make sure they're appropriate. Runtime is going to be a slightly different story, but that's why I'm going to address that a little bit later. Okay. Yes, Michael.
I don't understand the reasoning
Uh-huh.
why one has to be stricter in the sub.
Okay, so put it this way. Okay, intuition is really important because for the postcondition, it's completely symmetric, right? So now let's say clients over here. Let's say they're using a class A. Okay? And class A has a subclass called B. Okay? Again, let's say we've got a feature over here, require, and then P1. And then we got F over here, require, and then P2. Okay? In order for the design to be correct, so that means P1 implies P2, meaning that any value that can make P1 true can also make P2 true. Okay? Any input value that satisfy P1 can also satisfy P2. Are you okay with that so far? Okay, so now let me go one step further. Let me try to see what if it is not the case that P1 implies P2. What if it's not the case? Okay? So when I say it is not the case that P1 implies P2, means there is a witness, basically like a witness, like a value. There's a witness, for example, X, just in general. There's a witness X that can make P1 true, but P2 false. Right? When you think about the truth table, right? Do you remember the truth table? Actually, we review it, truth table? Let's do it. How about we do that anyway? Okay. Do you know what a truth table is? Okay, good. Yeah, at least you know that I'm happy, right? P and Q over here, okay? And then true, true. You know what? Let me do false, 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 true, true, false, true, true, okay? And then P implies Q. All right, how should I fill it in the table? Oh, tell me the one that should be true. Row number which? Okay, basically, false implies false would be true. False implies anything, basically, right? That'd be true as well. And then true implies false? False. So that's exactly this case over here, right? And then true implies true? True. Okay. Okay, Michael, let's go a little bit further. So that means if you can ever find a witness that can actually make P1 true but P2 false. So that simply means whatever input value that can make the static type A over here happy, which is what the client is expecting. But it will actually fail the precondition for the subclass. That's not good. Okay, good. Huh? Oh, actually it's about expectation, right? If I'm using a smartphone, of course, I don't quite know exactly what the smartphone is dynamically. So I want to make sure everything I know from the interface of the smartphone can be satisfied at least by the dynamic type. If it cannot be, then there's something wrong with the design. Okay, think about it.
I see.
Yeah, no worries. Think about it. Yes.
So the true-false case, is that exactly pretty much what we were talking about?
Oh, exactly. Yeah, exactly true. Yeah, where you actually you can think about the P here is like the precondition in the parent class, and the Q here is like the precondition in the subclass, right? So that means the input value can actually satisfy the parent's precondition, but it will fail the child's class precondition. That's
So
not good.
we know that like P2 can be stronger than P1, but would it also be a problem other way around if it was weaker?
Oh no, actually you see, if you say P2 is weaker than P1, that's exactly what the blue one is saying there. It's saying P1 implies P2. So P1 and P2 you can think about it's more like the appropriateness condition for you to prove. If you can somehow justify P1 implies P2 is the case, then that means your design is appropriate. If you cannot, then it's not appropriate.
Because like P1 and P2, P1 and P2 can be also like if P2 requires exactly the same thing.
Oh, if P1 is exactly as P2, let's say, in that case it's still because P implies P, right? Right. Good.
Why would there ever need the precondition for class B if everything is just passed at class A?
No. Actually, so it's for design purpose, right? Because when you try to redefine your feature in a subclass, you want to rethink about the precondition there, right? You might, yeah. So you might make it weaker, you might, but you don't want to make it stronger, right? Guys, any questions about this? Okay, I think it's nice, worth spending time on the precondition, but let's do postcondition quickly. Okay. Let's now go to. You can also read it. Okay, the slide is exactly what we talked about. I'm going to look at another one here. So now let's focus on postcondition. So now when you think about postcondition, the relationship is a little bit the opposite, right? So now we're going to focus on the postcondition for smartphone versus the postcondition for iPhone 11 Pro, okay? So now, do you see, basically we're doing beta and delta, right? Do you think the way we design beta and delta is appropriate? I heard no. Okay, think about it. Let me read it to you. Okay. Oh, by the way, just in case you're a little bit confused about the predicate here, so that should be bracket this way, right? And also it should be bracket this way. Let me read it out to you to see if that makes sense to you. I'm saying that for me as a user, if I'm using a smartphone, when I get reminders, given that the battery level is okay, given that, what it can guarantee to me is it's going to return back to me everything that happens today. Okay? But somehow, when you talk about this guy here, it tells me that it's going to give me all the events that can be either today or tomorrow. Intuitively, is this a problem? Why is that a problem?
It's a less strict postcondition.
It's a less strict postcondition because all I need from the list of reminder, I only want to be reminded for today, but give me something that's not relevant. Because in the extreme case, over here, it can just give me all the reminders about tomorrow, right? In that case, it's useless because I want to get reminded for today, but it give me all the reminders for tomorrow. So that's not right. Intuitively, right? So now, what would be? Again, I give you this question in the exam. How are you supposed to answer it, right? Similar pattern, okay? So now what we should do is, number one, what should we prove? Let's say if alpha and delta are appropriate. Let's say if they are. Then what should hold? Delta implies beta. That's correct, but let's remind ourselves what does really mean. That means everything that's expected. Oh, actually, sorry, let me say it again. So that means if, intuitively thinking this way, if somehow I can satisfy the postcondition for delta over here, it's guaranteed. At the same time, it will satisfy also the postcondition for the parent class. So that makes sense, right? Can this be proved? Is delta implies beta the case? Okay, if you believe no, how are you supposed to convince me? Counterexample, yes. What kind of counterexample would you give? Exactly, okay. I'll write it down, okay? So this is not the case. which means it's not a tautology. Okay? So now, counterexample. Counterexample over here. Okay, let's say the list of events contains only those tomorrow. Let's say in that case, okay, give me one more, let me finish this, and then I'll get back to you. So that's a counterexample over here. The list of events that contains only those for tomorrow. In that case, is it going to satisfy this? It is, because it's either today or tomorrow. However, is it going to satisfy the parent clause? No, because the parent clause is saying every event in the result should be happening today, right? So that's not appropriate. Yeah, question?
So in the fluid state, alpha should be beta.
Yes. Number one. Delta implies beta. Are you talking about this line here? No. Oh, yeah, exactly. Yeah, absolutely. Oh, absolutely. Thank you. Yes. Yeah. They look the same, don't they? Okay. You know what? I should really change to ABCD. Yeah. You know, the first time I taught this, I got a big problem of remembering their name. When I say delta, I meant beta. Yeah. Anyway, beta and delta. Thank you. Yeah. All right, guys, any questions? Okay, basically, for subcontracting, number one, get the intuition right. It's really good for you to judge the design. And number two, if I really ask you to judge, that's the formal formulation you want to present to me, and then give counterexample if necessary. Yeah. Preconditions? Yes. Which one? I mean the previous one? Yes. What if you just put it that way? What's going to happen at the runtime? Is that what you're asking? No. Okay, good question. Wuma's question was like this. I'll write it down. Again, you're basically saying A, F require P1. B, F require and P2. Okay, we say that before. In order for this to be valid, should be P1, sorry, P2 implies P1, is that right? Are you sure? For precondition, I'm checking on you. Should that be P2 implies P1 or P1 implies P2? P1 implies P2, okay, guys be careful, okay? That's why if you simply memorize, it's going to lead you too far, okay? So please, okay. To be valid, P1 implies P2, okay? First of all, that's what we said so far. Uma's question was like this, which is completely valid. Is it ever possible that our design requires the other way around, P2 being stronger? I would say possibly you might consider this scenario for your design, but that would mean you're going to break substitutability. Because if you got a P2 that's stronger than P1, what that would mean is, conceptually, when the client is using P1, they're using static type A. In that case, they're expecting P1. However, the dynamic instance, which is B, is requiring something that's more, so they can break. Okay, so the answer to that is, it is possible you may consider this possibility, but that means it's a poor design, because that would mean you're going to break the substitutability for inheritance. Okay, I'll write it down, and then in case you got more questions. Okay? So that would be a poor design because it breaks substitutability. In that case, I would say you may have to refactor your class a little bit. I can try to respond to that question maybe later. You may just have to reorganize it a little bit. Yeah. Yeah. Hey guys, any questions? Okay. All right. That's about pre and post conditions. And then let me see what the next topic is. Okay. Basically, 2.1, 2.2, and 2.3, we talk about the pre and post condition not being appropriate. And then for 2.4 and 2.5, I give you the appropriate versions. So go over them and then try to convince yourself why they're appropriate. Yes?
You said that you have to prove, say, for example, P1 implies P2, right? And then using to prove it, you prove by contradiction, right? By counterexample.
Yeah, I would say typically the proof you're required to do, it would be quite obvious to you whether that should be true or false, right? In the case you believe that's not the case, then you give counterexample.
Right.
Yes.
So that's that. But like if you prove by counterexample, you find an instance where like it would break the code. Is that sufficient? Because don't you also have to prove that there's a subset relation?
No. How do you prove, for example, in general? Let's say you got two sets over here. Let's say you got two sets, basically, right? When you talk about P1 implies P2, you're basically saying set 1 is a subset of set 2, right? As we said before. Oh, sorry. Thank you. Okay, so now, if you basically talk about set 1 and set 2, how do you prove? How do you disprove? How about that? How do you disprove that S1 is a subset of S2? Well, you basically just find an element that's in S1, but not in S2. That's exactly what we're doing. Okay. I'll just write it down just in case. Okay. If you want to disprove it, find X such that X is an element of S1, but X is not in S2. Okay, good. All right, okay. Let's go a little bit further. All right, so now, up to now, we basically talk about once you got your precondition and postcondition written down, maybe on a sketch paper or even your iPhone Studio, that's okay. We talk about basically how to judge whether your design is appropriate, right? That's require a little bit of analysis, intuition. So now we're going to talk about how exactly does iPhone Studio, well, does this particular programming system, how do they check your precondition and postcondition? Because what if, let's say the user, what if the programmer, accidentally or intentionally, they put a stronger precondition in the subclass? What if that happened? We know that's not appropriate, but it will compile, so you can never stop people from writing it. What's going to happen? Okay? So there is a certain rule we should know. At the runtime, they're going to somehow put together the preconditions from the subclass and also parent class by using certain logical operator, and also similarly for postcondition. So that's something we want to go over and see why it would be the case. Okay? And then we'll revisit the example that we talked about. Okay? Okay, first of all, if you want to redeclare or to add more precondition or postcondition, you say require else, and for postcondition, ensure then. Okay? So now, what would be the resulting runtime checks? That's something we want to see. Okay? Before I do that, I'm going to do a little bit of preparation. Okay? First of all, let me show you that. So this is saying, I'm going to justify. I'm going to tell you why. Let's say we have some original precondition in the parent class, and we have some new precondition in the subclass. Okay? We got two preconditions. Somehow, it doesn't matter what those two predicates are. iPhone will simply put them in disjunction. But what's the rationale? Okay? What I would do is, I'll use example to illustrate to you. That will be much easier. I just want to copy the code that we talk about. Okay, I'll just go back to the code over here. Okay, this is the example that we just talked about. Okay, so we talk about here, that's the precondition here, and that's the precondition over here. We know that it is not appropriate. Okay, I will just write it down. Not appropriate because, for example, 13%. 13% is going to satisfy this, but it's not going to satisfy that, right? Okay, so now, when you actually write this code in iPhone Studio, it's going to compile, and what if you run it? For example, let's say this. Declare S to be of type smartphone. And then dynamically, I'm going to say creates iPhone 11 Pro, okay? iPhone 11 Pro. That's the dynamic type. And then I will have, let's say, s.make. And then when I say s.get reminders, so now, exactly what precondition will be checked. Somehow, both of them will be checked, but in the disjunction. Let's see. Runtime check, I'll put it here. We will simply check to see the battery level. First of all, let's try this one. Larger than or equal to 10%, or disjunction like or else, right? Also larger than level is larger than or equal to 15%. So now let's use the same counter example over here. Conceptually, 13% is going to satisfy the precondition at the parent level, but it's going to create a surprise because dynamically this is going to fail, right? However, what's going to happen here? Would it be true? Simply because it already satisfied the parent's precondition, so that would be true. So you can think about this more like a protection mechanism at the runtime to make sure whatever you put down as a precondition for both the parent and child classes, it will be, of course, your responsibility to make sure P1 implies P2. However, if it was not the case, they can still protect your code by creating surprise. Basically, this guy over here should be should be weaker. When it's not weaker, it has no effects. No effect in the sense that as long as the left-hand side of the disjunction is satisfied, it doesn't matter what this is, right? Guys, do you follow the rationale here? Okay, let me just summarize quickly and they'll take a question. We basically talk about how you can design the contract, let's say for precondition. It should be the case that P1 over here implies P2. That's the validity constraint, okay? P1 implies P2. When it is not, when you want to judge the appropriateness of the design, you will simply say it is not appropriate. However, at the runtime, what the runtime will do is going to put them into disjunction. So even though this guy over here is stronger, but that's okay. As long as you satisfy the parent's precondition, overall it will still be true. Just protect. Yes. You will run. Yes. You compile and you run. However, having this simply means you don't really understand what's going on of design by contract at the runtime, in the inheritance, because putting something as a stronger precondition in the child class has no effects at the runtime, right? Yes.
So I see the case how this might not work if P2 or P1 doesn't apply P2.
Okay.
But it kind of seems like it's pretty useless to even have it there.
You mean have P1 or P2?
P2, because once P1 is there, like P1 is already implied that it's true.
Yeah, that's true. So, yeah. So the idea is somehow you want to say, if P1 is already satisfied, then For this particular precondition, we are fine.
So but why is it there in the first place? Like, what is it protecting us from? Because you have to go through P1 to get to
No. What it protects us from is like this, okay? Because you cannot stop the user from actually satisfying. Okay, let's say this. Let me make sure if I got you correctly, okay? First of all, whatever that's put under require over here, and whatever that's put under require over here is completely up to the developer, right? Nothing the compiler can control, okay? Conceptually, we will hope the programmer simply puts something over here that implies something over here. That's what we will hope. What if it's not the case?
Well, no, I'm actually saying even if it is the case, I'm asking why do we have the second P2?
Mm-hmm.
P1 already protects us.
Mm-hmm.
But like, what is P2 protecting us from? Because we already know that if it reaches like P2, we already know that P1 is screwed.
Yeah, I'll give you a little bit more example next time, but what you can do is, okay, that's a question. That's a good question. So what can you put in P2? You're supposed to put something that's more, you're supposed to put something that's less strict. Okay? I'll try to give you an example next time, but from the design point of view, whenever you are introducing a new precondition in the subclass, you are supposed to put something that's less strict. Mm-hmm. I'll give you more example next time. Okay, I see where you are stuck in. Yes.
I have two questions.
Mm-hmm.
So, say for example, because like if we have this example here where we have 10%
Mhm.
is satisfied with 15 isn't, would it still call like the child class, like the second one?
Oh, yeah, exactly. Okay, so let me make sure I understand you correctly. So we talk about this particular check, right? Okay, you're saying 13%?
Yeah.
Oh, okay. Good question.
Like because the top one is satisfied, the bottom one wouldn't be satisfied with
Okay. Have I mentioned short circuit to you guys so far? I haven't, right? Short circuit? Maybe no. Okay, maybe I mentioned in 2030, not here. Okay, no worries. Okay, might be worth mentioning. Mention it quickly. So now over here, I say or else over here, right? Or else over here goes something like this. Okay, let me put exactly this example here for you. Okay, it's basically level larger than or equal to 10% or else. And then I'll draw some connection to Java. Level larger than or equal to 15%. And the example we want to use is 13%. Okay? Basically, when you see or else in IFO, it's equivalent to this guy here in Java. And in order to understand what's going on here, there's something called short circuit effects, which is not unique to Java or IFO. Wow, basically, any programming language with a logical connection, they should have this. Okay, anybody tell me what short circuit is for or else? Okay, yeah, I'll let. Exactly true. Okay, for those of you who took 1022 with me or 2030, I mentioned this always, right? I think that's important. I'll mention it very quickly. For those of you who didn't know, that's okay. Thinking this way, very quickly, right? When you say or, think about the truth table. Let's say we got P1 and P2, and P2. Let's say false, 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 true, true, false, true, true. And then over here, let me talk about conjunction and disjunction. So that'll be, let me do both. Okay, let's talk about, first of all, P1 and P2. And also P2 and P1, okay? Oh, by the way, so the n% in Java in IFO is and then. Okay, that's why you see in short then. That's actually why. Okay, so now I'm pretty sure you know how the truth table works, right? Okay, I'm not going to bother you. I'm going to give you the answer right away. What would be the only scenario where you're going to get true for conjunction? When both are true, right? That's the only case. All the rest is just going to be false. Agree? Okay? And the only way you can make disjunction true is, let me say it again. The only scenario you can make disjunction false is by both false. Okay? Symmetric. Okay. In that case, you will get false, false. That will just be false. and all the rest would just be true. Oh, yeah. I keep making mistake. What am I doing? You know what? How about, yeah. That's the good thing about using iPad here. That's what I meant. And then over here, of course, what I meant to say is or. Then now that will make sense. Imagine how I can do this on the board, right? You'll waste time. Are we okay with the truth table? Okay, so that means whenever you're trying to evaluate conjunction with disjunction, right? So now when you say P1 and then P2, okay, and then P2, if I know P1 is already false, it's guaranteed the result will just be false. So I don't bother with the right-hand side. So it will be just false. Okay. Similarly, if I try to evaluate P1 or else P2, in that case, symmetrically, if I know that one of them is actually true, for example, right? In that case, let's say P1 is already true. In that case, it will just be true. So I don't need to bother with this. It will just be true. It's a very quick review, right? That's something you would have grasped, hopefully, in Java. I'm just reviewing it, right? Whenever you say n% in Java, it will be and then in IFO. Whenever you say or like a vertical bar, it's or else in IFO. Yes?
So regardless, it would still call it the child class.
Okay, so now let's go back there. Yes, this is why I want to do that. So now let's talk about this particular evaluation over here. So this is basically the evaluation for the precondition, right? So that's from the parents, and this is from the child. So now what's going to happen over here? Let's say the current battery level is 13%. Do we have to evaluate the precondition in the child class? We don't, because 13% larger than or equal to 10% is already true. So we don't bother with the right-hand side, which means we don't have to evaluate the child class. Yes. Okay, so now over here, this is already going to be true. So that means you don't bother. Overall, it will just be true. Overall.
So if we just require instead of require else, it would.
Oh, actually, it's just a syntax requirements. Over here, whenever you try to do the precondition in the child class, you gotta say require. You gotta say require else.
So what happens if you do a precondition that doesn't have else, you just do require?
What do you mean?
So like, let's say, for example, the one that we have is like 10% and 5%. What happens if we just wrote require instead of require else in the child class?
Okay, let me really make sure what you're saying. Okay, are you trying to say? Okay, again.
Like for example, like we see level precondition, you just wrote like require instead of require else.
Yeah, I see what you mean. What I would do is I'm gonna again make it clear to everybody. Let's say that's what you have, right? You are saying, what if I simply get rid of this guy over here? Okay, that's what you mean, right? It will not compile. Okay. Every time you want to refer to the same feature but with a different precondition, in that case you have to say require else. It's required. Okay. Okay. Won't compile. Similarly, what if you get rid of then? Also won't compile. Okay. Okay, that's pretty good. Okay. Do I have 1 minute? 2 minutes? Yes. Oh, wait. Question. Oh, does it really matter if smartphone is deferred or not? That's a good question. The answer is no, it doesn't matter. Basically, you can think about the way we accumulate the pre or post condition, just like how you accumulate the code. It's just that when we evaluate the contracts, either it has to be disjunction or conjunction. We haven't reached the conjunction just yet. Okay. Questions? Over here, you can see that this is a subclass of that, agree? Okay, and then when you say ensure, you gotta say ensure then, because there's already an ensure. Okay. Questions?
Does the iPhone have the ternary operator? Like the question mark?
Oh, I see. Oh, I see what you mean. For those of you who are very good in Java, you know that there's a syntax like a question mark and then colon. Any one of you is aware of that? Okay. No, there's no such thing in iPhone. Oh, no. Actually, you know what? They do. Now that I think of it. Let's say, for example, okay, that'll be the last topic for today, okay? And then we'll continue tomorrow. I believe you do. Let's say, for example, if I say x larger than 1, and then I would say 2y. Otherwise, I can say 3z. Well, it doesn't matter, right? That means if x larger than 1 is true, I'm going to return 2y. But the expression evaluated to 2y. Otherwise, we evaluate 3z. Quite interestingly, you do have correspondence in iPhone. Okay? You say if x larger than 1, and then you just say 2y. Otherwise, 3z. What? Is that a surprise? Oh, yeah, you can do that. I didn't make it up. Yeah, it's possible. You just didn't try, right? Yeah. All right. Okay, I'll see you tomorrow if you can make it.